So you would like to check whether this is convergent or not, and if it is convergent, whether it's conditionally convergent or absolutely convergent, right? Making sense? Okay. So now what first thing is what? Let's look at the absolute value of the values of the terms. And then first of all, we note that this series is alternating because signs of the terms, very good, okay, alternate, right? Now if I look at the absolute value of the terms, right, what happens is that these guys do this. First of all, they are all positive. I mean, I took absolute value, so they can't be negative, right? Okay. And then what happens is that this is decreasing, right? There was another requirement, okay? And if I take the limit, which is essential for convergence of a series, then this goes to what? 0, doesn't it, right? So that means as right. First of all, I cannot plug 1 in here because then this will become 0. That's why we started at 2. No, don't be sorry. We just like, okay, very nice. All right. So this was the, this is the alternating series test. We use these requirements, so it passes the alternating series test, so it is convergent, right? Now we have to check whether it is absolutely convergent or not, right? Okay. Right. So for absolute convergence, for the absolute convergence, excuse me, so what we have is we take all the absolute values of the terms, so that -1 to the power n is gone. And again, if I looked at this function, which is say 1 over x natural log of x, and we got x greater than or equal to how much? 2, right? Because that's where our series starts. So it is what? It is continuous on the interval from 2 to infinity, isn't it, right? Okay. It's also positive, right? It's decreasing, isn't it? So we can apply the integral test. What does the integral test do? It just tells you that if I look at this improper integral, then this integral and this series that we look at, they will have the same nature, right? Makes sense? And if you compute this integral, then what will happen? If you make a substitution, all right, what you will find is that it diverges, okay? Makes sense? So what happens? The series, right, does not converge absolutely, right? Absolutely, okay, but converges, so you call it what this term is. So therefore it converges conditionally, right? Makes sense? Okay, good. Now see if we had this series, okay, look here, let's take another example. See, if my series was, excuse me, let's say I have this, that is, say I got this cubed, okay, and then I have also and this is an alternating series. Okay, now in this case, notice this. You know that you will have to check for absolute convergence anyways, right? And an absolutely convergent series is also what? Convergent, right? So I would just go ahead and check for absolute convergence first. Okay,
If it's
so
absolute, then it's convergent.
very good. So that way it will save me time too. So if I look at this, right, then and now look at this integral. Okay, now we got, say, ln of x cubed, right? Here we are, and this does what? Well, this meant ln of the square of ln of natural log of 2. That's what it had meant. So this is convergence. It converges absolutely. So converges conditionally as well. I mean, it just converges then, right? Makes sense?
It becomes 0, right?
Which value? No, see, as you take the limit as x goes to infinity of the value, that will be 0, and at 2 the value will be 2 when you compute the integral, right? And you remember how to compute the improper integrals, right? Okay. Now how about this one? What would you say for this guy here? Let me just write another example. Now say we got something like this. Say here I have n square. Hi, how are you? Very good, very good.
How was your trip?
Oh, fantastic. So see, this is also an alternating series, right? Isn't it? Makes sense? Now tell me this. Look at it and tell me if it converges or it doesn't. What would you say?
It converges.
Well, why? Notice this. See this here? Yeah, I know we are in a kind of a hurry for this one because we got only an hour. See, for convergence, we always have to look for the limit of the nth term, right? And that's very essential. So what's the limit of this term as n goes to infinity? Look at the n square over 2n square plus 3. What's the limit?
0 by 0.
It's 0 over 0 form, right? So you can use L'Hopital, so as you keep going. Or just look at this. I have a polynomial of degree 2 here, right? Polynomial of degree 2. So
Maybe 1 by 2.
very good. 1 over 2, right? Very
It converges, right?
The nth term converges.
Oh.
But if always keep this in mind, okay? But if the limit of the nth term is not equal to 0, the series diverges, right? Okay, so what we got here is diverges. We wouldn't even worry about absolute convergence anymore, right? Makes sense? So see, we just saw this here, that it's okay, that this series is what? This is a convergent series, right? Makes sense? Now, say I have to estimate the sum of this series, right? Okay, so I mean, if I go from here, what am I doing? Look at this here. I'm looking at this. How much is the sum? 1. Okay, so this is the sum of what? The first 2 terms, isn't it, right? Okay, now let's keep going. Then here we go. Say this here. So this is the sum of how many? First 3 terms, right? And it's increasing here. So let's go a little further. Let's go like, say, 10, right? So it'll be the, so, well, well, it's yeah, it's alternating. So the thing, right?
Okay.
Exactly. So it's not necessarily okay. So let's do this here. Okay. Now it's like, you know, decreasing or whatever, but the thing is that it's okay. That's okay. We have open door policy, so we have to, like, you know, we have to keep the doors open, and that's nice. Okay. So it's getting somewhere, isn't it, right? Now, question is this: how many terms must we add? Okay, so that so that we are able to find the sum of these. Say I added these many terms, right? Am I making sense? Okay, so the thing is this, that let me add more. Say I added 100, like 99 terms here, right? So this sum is this, right? Makes sense? So I would like to know, okay, that what is the difference between what? Yes, I may help you. Okay. Okay. So what is the difference between this and this? Rather the absolute. See this here? This is the sum. This is the limit of the entire series added, right? And what is this? This is only the first 99 terms, right?
So we can take any number, or we have to take till 100, something like that.
I mean, see, I added only 100 terms, okay? All right. So look here. So if I looked at this, and we are looking only at the absolute values, right? So we would like to know, size of this guy, that, how much am I missing, right? Am I clear? Now look here. Here we have all the terms from 2 to infinity. Here we got from 2 to 100. Okay. So what happens is, this is, we know, oh, very nice. So this goes from 100, n equals 101 to infinity, right? Now, if we have an alternating series, okay, then what it tells us is this, that is, see this, if I'm looking at this, then this value will be less than,
The given.
very good, if I did this 1 over, okay, and I'm starting here, 1 over 100 times ln of 100 cubed, okay, then this is a size of this thing. So say if I stopped adding at this, then my error is less than what? Less than that, right? Make sense? Okay. So it's the same way. For instance, say somebody wants me to do this, to find n, okay?
But here it's given n equal to n plus 1 to infinity.
Yeah, exactly. That's what I'm going to go towards, okay? So if I have to find n such that what? Here. That's it. See here, the error is what? 0.0001023, etc., etc., right? So say I wanted to find n such that this.
Given value here.
Yes, right.
0.0001.
Right, exactly. So I want to find n such that, that's the case, right? Am I clear on this? Okay. So what I would do is, so I know this, that this value here is less than how much? 1 over n, then ln of, where are we? That cubed, right? Is that clear? See, 1 over n times ln of n cubed, right?
How?
Oh, okay. See, that's what the remainder of the alternating series theorem told you, that if you stop adding it at capital nth term, right, then the leftover is less than the absolute value of, okay. Actually, I made a mistake here, okay. It should have been this, okay. All right. It should have been n plus. Very good. Okay. So see, that should have been that. All right. So I have to do this now, correct my mistake, right? Okay.
N plus 1.
N plus 1, very nice. Okay, so there we go. What? N plus 1, right? Am I making sense? Now, a good thing in here would be this, that we may look at a table of values in our calculator. Okay? Makes sense? Now, since the calculator will be very small, I'm going to show that to you in a spreadsheet, but you know how to obtain your table of values in a calculator, right? Okay, so 1 second. So here you go, right?
But I don't use those things when I solving. I just use this calculator.
Right. So in calculator, remember, you can enter the function. I'll show you in the calculator also. So right now I'm doing this because this will be a little more screen friendly. Okay. And then I'm going to show you in the calculator right after this. Okay. So don't worry about it. So here, okay, I don't need, okay. So this is my n, right? And here I'm going to type what? I'm going to type n plus, oops, sorry, 1, right? Then times L, sorry, ln of n plus 1 to the what? Third power, right? Okay, or let me just be a little careful here. I'll just do this. Okay, one moment. Third power, right? So this is what I'll have here. Okay, so then we will go like 100, and I'm putting 101. Okay, and let's see how far it will have to go. Okay, and then I got this 1 over, see this here, this one, oops, sorry, plus 1, right? Okay, makes sense. And then what I got again, this plus 1, okay, and then we have, I hope it takes a natural logarithm, very nice. So that's what it does, right? Okay. Plus 1, right? Okay. Then to the power, oops, 3, okay. I should correct everything. Yeah, here we got it. Okay, so it's like point. So see this here. Now one thing is
What does it mean? E minus 0, 10 to the power minus 7?
is 10 to the negative. Let's check whether it's 10 to the negative 7 or e to the negative 7. Okay, let's check. I don't. Yeah, I think it says capital E, so that means it's 10 to the negative 7. Okay.
So it's okay.
Right. So that should be fine now. So in here, like say this here, let's check. It will tell us the value right here. Okay. So here we got 100, right? Makes sense. No, actually, you know what? See this here, we have that, and if we look at this, then so ln of n plus 1, yeah, let's check it real quick. So this would be 9.97. It says, one moment, let's check. Okay, why is it? Because 97259, okay, times e to the negative 7. Let's see. Okay, yeah, I think yes, that's what it means. It means like So here it's indicating e to the -7. See this here? Okay, but you can always convert it in terms of 100, 10 to the power, right? Makes sense? Now let me just show you how would you do that on the calculator. On the calculator we would just have this, right? Okay, here we are.
So how to find the sum, you mean?
Right, the same thing, the same table of values, right? So first thing we will do is we will enter our function, right? Oops, sorry about that. Divide. Come on. Then we have x plus 1, and then ln, where are you? Right here. Okay, and then we got x plus 1, right? Okay, to the power 3, but the trouble is, let me insert another bracket here. Okay, so all right, so then I have to the power 3. So we have the same function entered, right? Makes sense? Okay, so now we will let's go to the table, and of course at 1 we have an error, right? Okay, let me see if I want to go to, excuse me,
What did you do to go to the table?
I just the table, right? Exactly. Okay,
Or table set?
we can go to table set, and here we can say, all right, start at.
I got it. Okay.
You got it? Okay, very good. Now let me first enter so that. So here you can see. Now here, capital E means 10. That's what it
10
means.
to the power minus.
Yeah, so here 10 to the -4, etc., etc. That's how it's going. Okay, makes sense. So you can use use your calculator to get these values to that tune. Okay. So what we would like to do here is to so first estimate the above integral, right? So that the error of the error of the approximation is no more when, say, this is what your order is, right? Making sense? So what we do in this case, of course, we don't know how to integrate it directly, okay? We might use Maclaurin series expansion, right? So what does it mean is that, see, if we put or substitute x cube in here, then this becomes what? X cubed, right? Now x cubed to the power third is how much? X to the 9. Then power 5 would be
15.
X to the 15, right? Then this would be how much? X to the 21, right? Okay. Now if I take the antiderivative of each of the terms, right, then and this is, in our realm, this is a convergent series, right? So I can integrate it term by term, right? Okay, so if I did this, and I'm just doing a shorthand in writing, so pardon this thing.
It's okay.
Okay, yeah, right, very good. So this would be what? X to the 4 over 4 minus x to the 10 over 3 times 10. Just like it, right? We could have written 30, but 3 times 10 is all right. 3 times 10, right? Then we got what? Plus x to the 16. 3 times 16 here, right? Then x to the 22, oh, over 7 times how much here? 22, right? Okay. And now we are going to take the definite integral, right? So if I talk about the definite integral here, okay, then we're going from 0 to where? 0.1, right? And I have left it here. We will just, and since the lower limit is 0, everybody will disappear there, right? Good. So here we have what? 0.1 to the power 4, right? Then we have again 0.1 to the power 10, and here we got 0.1 to the power 16. Okay. Then we got what? This, and we will go for more if needed, right? Okay. So let's see this here. How much?
Just we guess, right?
Right. Yeah, right, exactly. Now we have, and I think this will do the job. Let's look at this guy. See, this is much smaller than 0.0001, right?
Yeah, much smaller.
Exactly. Let's look at this.
So we have to check another one now, right?
No, I'm just saying, it's even if we took this for approximation, we are good, right?
The first one?
Yes, exactly.
Yeah, because this is very much lesser.
Right, the 0.00, but so even if we left, and you can see this, like remember first you had done this, that is, say sine x, okay, and tangent inverse x, you know, they're all near 0. They're pretty close together, right?
The first one also lesser than that one.
Yeah, but you have to find a sum, right? So even if you did this, like you took this, so it's asking you for this sum, and here we can afford to be very lazy. That is, if we said, okay, this is approximately how much? Just the first term, all right? Like sine of x is approximately x near 0, isn't it, right? So this value is approximately this, and let's have the computer compute, and you can have your calculator compute this as well, right? Look at this. So this is again, so
How did you get this one?
oh, I just used the calculator, this one, this computer, and you can use your calculator for that. For instance, if
No,
you,
I got that, but how did you get this value?
which value?
This is from the first, right?
This is the first,
First term.
and this one I just used the computer when you are not watching the screen. Okay, I did it like this. Let me just show you in a different way. Okay, so we are looking at tangent inverse of x cubed, right? Makes sense? Now, if we did this, see, this calculator will give you the definite integral right here, 7. Okay.
Oh, so
So
you
it,
just plug in 0 to 1.
right. So it'll ask you for the lower limit. Okay. So for the lower limit, we say is 0, right? Okay. Then it asks you for the upper limit. That's 0.1, right? Okay. And when you do that, okay, where is the, I think, where is the value? Did it do that already, or? Okay.
Maybe it's calculating, it takes.
No, it won't take that long. See, lower limit is 0, right? Upper limit is 0.1. Yes, it does show you 0.000. Okay, right here.
So this is just this value.
Right.
This is not the summation of
You see, it even stopped right here. But here we are getting like more precise calculation. So this one here is a slight overestimation. Okay, but very slight, right? Are we making sense?
Yeah.
Good. Okay.
So